Hello, my name is Bob. I'm a math mentor, and I'm trying to teach you children about probability and statistics, specifically 3.1 and 4.1. And today we'll be starting with the probability experiment. An action or trial with specific results are obtained, and the result of single trial is an outcome. And the sample space is a set of all possible outcomes. So an event is a subset of the sample space. Okay, got it. Now, fundamental counting principle. The number of ways that events can occur in sequences is found by the multiplying of the numbers of the ways that events can occur. Got it? Got it? Wow, great. Okay. So the types of probability are classical, where each outcome is a sample space equally likely to occur, and the empirical, or statistical probability, which is based on observations obtained from the probability experiments. The empirical probability is an event E is the relative frequency of the event E. Okay. And the third type of probability is subjective probability. Subjective probability results from intuition, educated guesses, and estimates. For instance, given a patient's health, an extended of inquiries, a doctor may feel that the patient has 90% chance of a full recovery, or a business analyst may predict that the chance of employees can certain companies going on strike is 25%. Do you understand? Wonderful. Now, for complementary events, the sum of the probabilities of all outcomes in a sample space is 1 or 100%. That is the rule. An important result of this fact is that you know that the probability of an event E, you can find the probability of the complement of the event E. Wonderful. And the complement of the event E is the set of all outcomes in a sample space that are not included in the event E. The complement of E is denoted by E and is read as E prime. Do you understand? Wonderful. Okay. On to the next one. My favorite, a tree diagram. Wonderful. Okay. A probability experiment consists of tossing a coin and spinning the spinner shown at the left. The spinner is equally likely to land on each number. Use a tree diagram to find the probability of each event. So, in a tree diagram, you have to look at different events. Event A, tossing a tail and spinning an odd number. And event B, tossing a head or spinning a number greater than 3. The solution from the tree diagram at your left, you can see that there are 16 outcomes. There are 4 outcomes in event A, T1, T3, T5, T7. So P, tossing a tail and a spinner and an odd number, 4/16 equals 1/4 equals 25.25. Wonderful. Alright. Now, on to simple events. Simple events are the events where one experiment happens at a time and it will be having a single outcome. The probability of single events is denoted by P, parentheses, E, parentheses, and not the PE that you had in elementary school where you had the fitness circuit. That's a different PE. Where E is the event. The probability will lie between 0 and 1. For example, tossing a coin is a simple event. Got it? Wonderful. Okay. What do we have next? The law of large numbers. That is our last thing for 3.1. And it's very simple. The law of large numbers says that as an experiment is repeated over and over, the empirical probability of an event approaches the theoretical or the actual probability of the event. Well, that is all for 3.1. Now, on to 4.1. Oh, hold on. I don't know anything about 4.1. I think it's time to call my lady friend. Hold on. Oh, I had to go get the telephone. Okay. Tick, 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 tick. Tick, 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 tick. Ah! Susan! Hello? Hello, I need you to help.
Hey.
Oh, hello, Susan. It's so happy to hear from you. Okay. I need your help with something. I'm trying to teach these children about probability and statistics, and I already taught them about 3.1, but I have not taught them about 4.1, and I don't know anything about 4.1. It deals with like random variance and the discrete probability distributions and all that good jazz, but I just don't feel confident in teaching it, so I need you to help me.
Okay.
Okay, wonderful. Thank you. Alright, be over here in a Diffy Daffy.
Okay. Hi. Bob called. I guess I'm here to teach y'all about 4.1. So, first in 4.1, we have random variable. So, a random variable is the x value that represents a numerical value associated with each outcome of a probability experiment. And a discrete probability distribution is something that lists each possible value that the random variable can assume together with its probability. Okay, so if you're going to graph a discrete probability distribution, you let x be a discrete random variable with the possible outcomes, for example, x1, x2, x3, and so on, and then you make a frequency distribution for the possible outcomes. After that, you find the sum of the frequencies. You find the probability of each possible outcome by dividing its frequency by the sum of the frequencies. And then you have to check that each probability is in between 0 and 1 inclusive, and that the sum of all the probabilities is 1. Now we're on to mean, variance, and standard deviation. So the mean of a discrete random variable is given by the equation on the board, and each value of x is multiplied by its corresponding probability, and the products are added. The mean of a random variable represents the theoretical average of a probability experiment and sometimes is not a possible outcome. If the experiment were performed many thousands of times, the mean of all the outcomes would be close to the mean of the random variable. Oh, and variance. Variance is this equation, and standard deviation is this equation. So, expected value. A random variable, x, represents a numerical value associated with each outcome of a probability experiment. So a random variable can be discrete or continuous. If it's discrete, it has countable number of possible outcomes that can be listed. But if it's continuous, it has an uncountable number of possible outcomes represented by an interval on the number line. And yeah, that's 4.1.
Thank you!
So now